All right, you guys, so you should have the first 2 pages of the notes titled Shapes of Graphs. This is starting on page 11, so if you haven't already labeled this page 11 at the top or somewhere, please do that. So again, in this unit, we're working with data, okay? So we worked on collecting data, types of questions that get us that data, how to organize that data, and then how to analyze. So we're in the last set of notes that helps us analyze the data that we've collected in the organizational representation that we've created. So again, we've learned about dot plots, histograms, and box plots, all right? When we take this data though, and we make these 3 types of graphs, it can take a few different shapes, all right? So first of all, in these first 2 pages of notes, we're gonna be learning about symmetric shaped graphs and bell-shaped graphs. There is a sort of umbrella that goes with symmetric. So bell-shaped, bimodal, and uniform are all versions of symmetric shaped graphs, which again just means that like they look the same on both sides, okay? So right now we took this data and this dot plot looks symmetrical. If I were to chop it in half, again, this side is a mirrored image of this side, all right? Same thing with a histogram. Histograms though can be a bit more finicky because again, they're organized in intervals. So if we chop it in half, they roughly look the same. So this goes up, this side comes down, all right? So again, kind of like a mirrored image. Box plots are a little bit more elusive. You're not gonna know by the shape of a box plot specifically what type of symmetric graph, whether it be uniform, bimodal, or bell-shaped. But if it's equally distributed, or if this side looks like this side, you'll know it is some type of symmetric graph, all right? So let's go down below to page 11's first 2 bullet points. So we've got the histogram and box plots both, show, you're gonna have to add in this one because I forgot to give a line. Both show symmetric distributions. But again, you can't quite see what type of symmetric graph it is based on their shape, all right? However, dot plots, because they show each and every data value, give more detailed information about the shape of distribution. So you're gonna be able to tell with a dot plot specifically which shape it is. So that's page 11. Let's turn over now to page 12. Again, we're gonna be talking about symmetric distribution and bell-shaped distribution. So symmetric distribution is kind of like an umbrella. And at this point in time, you actually can stop taking notes for a moment, put your pen down, and you do not have to draw this, all right? But when I say it's kind of like an umbrella term, I want you to picture an actual umbrella, all right? So here's my umbrella. This umbrella includes anything that's considered symmetric. So again, we're gonna talk about bell-shaped in just a moment. It also can mean that a graph is uniformed. Actually, it doesn't have an E at the end of it. Or the last type, a graph can actually be bimodal. Tonight, again, we're just gonna focus on a little bit more with symmetric and bell-shaped. I'm gonna erase this now. Again, you do not need to draw that or write that. All right, let's come back now to page 12. If you haven't labeled page 12, start there. So because symmetric distributions mean that the lower half of the graph is the same as the higher piece of graph, the mean, otherwise known as the average, is always gonna be equal to or the same as the median, which as you know is the middle number. All right, so the mean will always equal the median. And the frequency, so the data that occurs the most, is the highest in the center of that data display. So if you look at these pictures down below, again, here is the middle, here are the middle pieces, and here's 50% of the data. All right, most of the data occurs in the center. So because of that, it makes the measures of center, actually not measures, center, we want to put here. So mean and median are measures of center. It makes it a good description of the data as a whole. So the things that are happening here, whether it be ages or whatever you're collecting, the majority of people who respond to this is going to be here. What's typical, what's average will be in the middle. Now, lastly, we've got bell-shaped distribution, all right? So the data has a dot plot that takes the form or the shape of a bell, like you saw me draw earlier, okay? You can see it a little bit on the histogram as well, but on the box plot, you can't see this at all, okay? So again, this has most of the data clustered at the center and fewer points farther from the center. So as we get out, these whiskers have less data. These histogram bars have smaller frequencies. Same thing with the dot plot. All right, there's less dots on the sides. Bell-shaped distributions are either always symmetric or close to it, okay? So like this histogram, is it the exact same on both sides? No, but it's roughly symmetric on both sides, okay? Same thing with the dot plot. Like I could have maybe one more dot, throw it off or something like that, and it's still gonna be considered roughly symmetric. Now, on your homework, if you're doing the sheet that I gave you, only do the first two boxes, parts A and B, or 1 and 2, however you're looking at it, and you can leave the more open-ended question down at the bottom for class, all right? Thank you for watching the video.